Thank you so much for joining this lesson. Thank you for joining this lesson. Continue following us. You can click the share button and invite a friend. What we are going to handle today is longitudes and latitudes. That is a topic already communicated that we are going to learn from it. Therefore, I request you to invite more friends as we continue learning together. You can comment. You can also subscribe. Kindly communicate. Let me know where you are listening from. Let me know where you are listening us from. Click the share button and invite some classmates, some friends. Yeah, tell them to join us. This is the best platform. This is the best. Tell them to join us. The best platform. Yeah, continue joining. So we are going to summarize longitudes and latitudes very quickly. Then after that, we are going to see some questions from the same topic. Remember to subscribe. Remember to subscribe as you continue watching. Thank you. I can see the numbers are increasing. You can see the numbers are increasing. All right. On longitudes and latitudes, we start by, first of all, knowing what longitudes are and what latitudes are. Longitudes are imaginary lines running from the North Pole to the end, of course, of the Earth. Then longitude is usually the Greenwich meridian. That is also called the prime meridian. It is usually 0 degrees. So all the other longitudes are now named either to the east or to the west of the prime meridian, and they range from 0 to 180 in the east, and also 0 to 180 in the west. All the circles of longitudes are equal because they are all running from the North Pole down to the South Pole. So we say they are equal, and they are called great circles. Therefore, great circles are circles of longitudes which run from the North Pole to the South Pole. You can see a diagram here whereby we are saying the reference one is called the Greenwich meridian, which is usually 0 degrees. It is the one I'm calling a prime meridian at this point. So we can have other longitudes now being named now. When you go to the right, that is the east direction. For example, I have a longitude here in green. I'm calling it 40 degrees in the east. There is another one to my left. Those ones are to the west, and we call them, yeah, they are to the west. So that is, for example, 100 degrees to the west. So those are what we call longitudes. They can be as many as possible, all the way to 180 on either directions. Let me talk something about latitudes. Latitudes are imaginary lines that run from the east to the west. So they run in an east-west direction. And that is also the rotation of the Earth's direction. The reference latitude is usually 0 degrees equator. Therefore, equator is the reference latitude. All the others now are named with reference to the equator, depending on the hemisphere on which a certain latitude is. It's good to mention that the equator, which is 0 degrees, as you can see on this diagram, the Earth's globe, or rather the Earth's, into two halves, which we call the hemispheres. So the one on the upper side is called the North Hemisphere, and the one below the equator, we usually call it the South Hemisphere. So it's called the South Hemisphere. As you can see, there are what we call latitudes. And we are saying that circles of latitudes are called small circle because they decrease in size as you move from the equator, either towards the North Pole or towards the South Pole. The latitudes do not have equal sizes. They continue decreasing as you go down or as you go up to the North Pole. And therefore, due to that, we say that circles of latitudes are small circles. Something to the circle of the equator. Therefore, you can see the latitude equator, which is the 0 degrees, the reference latitude, can make a circle. Remember, the Earth is in 3 dimensions. It's a sphere, not just a circle which is in 2 dimensions. This is in 3 dimensions. Therefore, we are talking of now the circles due to these lines. So if you follow through a latitude, then it will go around until it makes a circle. And the circles which are made by latitudes are called small circles. It's good we look at the position of places on the Earth's surface. And that the position of a place on the Earth's surface is described as a coordinate following the latitude and the longitude in which where the place lies. Now we give it as the position of that place. So a place is described by the intersection of its latitude and its longitude as a coordinate in that order. We begin with the latitude. Let us consider the case here, whereby we have some longitudes, some latitudes intersecting to locate some places. For example, when you look at okay, we have the 0 degrees equator, and there is also the 0 degrees prime meridian. 0 degrees prime meridian. Therefore, with those 2 reference lines, then we are having a latitude 40 degrees here in red, another latitude 50 degrees here in the south. And now we can talk about some longitudes like 60 degrees to the west. And we are also having another longitude, which I'm calling 30 degrees. This one, 30 degrees in the east. Therefore, those are some lines already which are intersecting. When we look at point A, for example, that is an intersection of a longitude 40 degrees north, and that is a latitude 40 degrees north and longitude 30 degrees in the east. Therefore, the position of A will coordinate starting with the latitude, then the longitude, where point A is. There is also point B. Point B, it's here. Now, point B on the same latitude, 40 degrees north, but the longitude now is 60 degrees in the west. And that is how we will get the location B. Then there is C on the southern hemisphere. So at the southern hemisphere now, we can all see that point C is at 50 degrees in the south, that is the latitude, and 60 degrees in the west. So that is how we describe the position of C. There's also the position of D on the southern hemisphere, 50 degrees in the south, but the longitude is 30 degrees in the east, where A is lying. Therefore, now we have the position of D also described. Therefore, it is easy to describe the position of a place because you just need to identify the intersection of the latitude and the longitude. Then you know the location of the place. Continue inviting friends, continue liking, continue subscribing. You can leave a comment for us. Tell us whether you can hear clearly. Tell us whether you can see the screen well. Let me know how everything is happening. Yeah, there is what we call longitude differences and also difference. when places are on different longitudes, we talk about longitude differences. If places are on the same side of the prime meridian, then longitude difference will be the subtraction of the respective longitudes. The subtraction of the respective longitudes. But if places are on the same, on opposite directions, or opposite sides of the prime meridian, then we will say that a longitude difference between them is the addition, or rather the sum, of the respective longitudes. Let me clarify this using some examples. We are talking of a longitude 45 in the east and longitude 60 in the west. I can also see longitude 100 still in the west. So the longitude difference between a place which is lying on 45, let's say place P, and another place Q, those are two places on opposite sides of the prime meridian, because the prime meridian is the one here. This is 0 degrees prime meridian. Therefore, if P is to the east, that is 45, and Q to the west, that is 60, then the longitude difference is simply the angle between the two places. And that is why I'm saying, because they are in opposite sides, we are going to add. At this point, we are having 45, and at this point, there is 60 degrees. Therefore, we add 60 and 45 to give us 105 degrees. Then there is also PR, whereby P is to the east, 45, R is to the west, 100 degrees. Therefore, we'll be talking about, again, addition. So the angle difference, or rather, the longitude difference between P and R will be the addition, 145, giving us 145. There is also Q and R. Now, for Q and R, they are on the same side of the prime meridian. That is, they are both to the west. Therefore, the angle between them, this is logically moving from 60 degrees in the west up to 100 degrees still to the west. Therefore, the angle difference between such places will be 100 minus 60, and the angle difference between the two places will be exactly 40. Therefore, angle difference when places are on the same side, we subtract. Angle difference when places are on opposite sides of the prime meridian, in such cases, we usually add to get the angle difference. And the same will apply to longitude differences. Let's say, for example, following the diagram here, we can see point A, which is at 50 degrees in the north, and there is also point B, 20 degrees to the south. So point C, which is 65 degrees to the south. Latitude difference point A and B will be moving from 50 degrees to the north through all this angle until we arrive at 20 degrees in the south, and that will be through an angle of 70 degrees. Therefore, the latitude difference will be equal to 70. The latitude difference will be equal to 70. Again, when we'll be talking about 50 in the north and 65 in the south, that is moving from 50 all the way down to C, which is 65 on the other side. And the whole of that angle is going to be, again, the addition, and that will be 115 degrees. Let us talk about BC now. We are moving from south, 20 degrees, going to south, from south to south, from 20 degrees to 65 degrees on the same side. So the latitude difference in such a case will be 65 minus 20. The angle difference between such places will be the subtraction, and that will be 20 or 45 degrees. So it's good for you to know that latitude differences When places are on the same hemisphere, we subtract. But when places are on opposite hemisphere, longitude and latitude differences. Let us look at distances along the Earth's surface. We're just looking at a summary of the topic. Then later, some questions now, which will be applying what we are talking about in this case. Let us look at distance along a great circle. Sorry, I didn't write the topic well. I wanted to mean circle. Distance along a great circle. A great circle. Let us look at how we can calculate the distance along great circles. Along great circles, it means these are circles of longitudes, places along longitudes or along the same longitudes. For example, let us consider the diagram below, whereby this is a 0 degrees equator. Then we have a 0 degrees prime meridian. They are both in red. Then the yellow longitude, we can have it as a longitude. Let's say this one is longitude 50. You can see it is to the west of the prime meridian. Yeah. Then now we talk about the latitudes, where the two places are. Let's say this is a place A, then we are having a place B at this end. Now the distance AB is just an arc. The distance AB, that is along a great circle. We usually calculate it just like the way you can calculate the length of an arc, any other circle's arc. You know the formula that getting an arc length is usually given by angle at the center divided by 360, 2 pi radius. But now in this case, we are going to say the arc AB is going to be given by the angle between the two places from A to B. Now you will have to add the latitude of A. Let's say this is a latitude 60 degrees north, and the latitude of B, which is a, let's say 70 in the south. Therefore, you'll be talking about now an angle difference of from 60 in the north all the way to 70 in the south. There will be an angle of 130. Then this one can be divided by 360 times 2 times pi, 22 out of 7, times the radius of the Earth is usually a constant, and that is equal to 6370 kilometers, unless communicated otherwise. Therefore, generally, you can now compute that and get to know the distance. But generally, we are saying distance in kilometers along a great circle is usually given by theta divided by 360 multiplied by 2 multiplied by pi multiplied by capital R. In this case, we say where theta is the latitude difference. Theta is the latitude difference. The latitude difference, and R is the radius of the Earth. It's the radius of the Earth. Radius of the Earth. Radius of the Earth will always be provided. That is usually a constant. That is in kilometers. A great circle again. Distance can also be given in other units, which are called nautical miles. Distance in nautical miles, nm, is usually given by 60 multiplied by theta, where again theta is latitude difference. Latitude difference. Because the two places are on the same longitude, we want the latitude difference now. We can now talk about the latitude difference, and that will help us to get the distance in either units. So those two units can be used to measure distances or to calculate distances along the Earth's surface. Those are very key for distance in kilometers along a great circle. It's given in that formula. Distance in nautical miles along a great circle is also given by 60 multiplied by theta. So also master that. Let's look at now distance along a small circle. A small circle is a circle of a latitude. Circles of latitudes. Circles of latitudes. And circles of latitudes. Circles of latitudes. It's good to know that latitudes, we said they don't have a uniform radius. They decrease in size. They decrease in size as you move towards the North Pole or towards the South Pole. Let us consider a circle or a small circle described on this diagram. Let's say, for example, the latitude itself. We are considering a place A and another place B. They are lying on let's say from the center of the Earth. You know, from equator we name latitudes. Therefore, this latitude can also be named following a certain angle here. Let's say there is angle theta here. Then again, on the other side, there will be the same angle. But let me drop a perpendicular now at this point. I want us to identify the radius of such a small circle, because such a circle will not be having the radius equal to the radius of the Earth. The radius of a small circle is usually different and smaller. So from this point, we are going to say now up to the center of the circle, this is going to be the radius of such a small circle. Therefore, the small circle now will be having its own radius, not equal to the radius of the Earth. But something you should know is that from the equator at the center of the circle, all the way to where point A is, there is the radius. There is the radius of the Earth. Then now we are saying that the radius of such a small circle can also be dropped here. It will be equal to the length at this point. It will be equal to the length at that point. Therefore, we can describe the size of this angle is the name of this latitude. The size of this angle will be the name of the latitude. Therefore, I want us to agree that the cosine of the angle there, the cosine of the angle there, we can call it theta, will be given by the adjacent length, which is small letter r, divided by the hypotenuse, which is now radius of the Earth. And with this, we can remain with radius of the small circle, which will be given by capital R multiplied by cosine of theta. Remember, theta in this case is the latitude itself. Theta is the latitude itself. Therefore, the size of the small radius for the small circle will be given by capital radius multiplied by cosine of the latitude itself. So we are saying small letter r now can be concluded that it's given by capital R, radius of the Earth, multiplied by cosine of the latitude where the place is lying. And therefore, just like any other arc length from point A to B now, we are going to say that the distance in kilometers along a small circle will be given by angle alpha divided by 360 multiplied by 2 pi small letter r. But now we have said that a small letter r is given by capital R cosine of latitude. Therefore, we can say that alpha divided by 360 multiplied by 2 pi. Instead of small letter r, we can have capital R, then we multiply by cosine of the latitude where the place is lying. And in such a case, we can say that alpha is the longitude difference. The longitude difference. It's the longitude difference because the places are already lying on the same latitude. Therefore, the angle now at the center of such a circle will be from this longitude where A is to the longitude where B is. That will give us the angle at the center. Therefore, you will discover that now we are extracting a small circle AB such that there is the small letter r now, and now there is the angle difference here, which is the latitude, which is the longitude difference now. So the arc length will be given by alpha divided by 360 multiplied by 2 pi capital R, radius of the earth, multiplied by cosine of the latitude where the place is lying. And with that, we can also talk about a distance along a small circle in nautical miles. This will be given by 60 multiplied by alpha cosine of the latitude. So distance in nautical miles along small circles, distance in kilometers along small circles. Those are very key formulas, Let us look at longitudes and time. We usually say that the earth is rotating in an east-west direction, which means that places in the east are ahead of time of the places in the west. And now it's good to also know that places in the west are behind in time. Let us look at a simple example here, or simple illustration. If we say that the earth, to make a complete rotation around the earth, it takes 24 hours. 24 hours can be converted into minutes by multiplying by 60. So when we multiply 24 hours by 60, we get 1,440 minutes. Therefore, we say for the earth to go through the whole globe, to rotate the whole globe of 360 degrees, it takes 1440 minutes. What about a rotation of just 1 degree longitude? Because we said longitudes are moving from 0 all the way to 180 west, and again all the way to 180 in the east, which means now if the whole globe 360 is rotated through 1440, then 1 degree is rotated through 1440 divided by 360, and that gives us a longitude difference of 1 degree requires 4 minutes. There is that relationship which is supposed to be understood and applied. For every longitude difference of 1 degree, there is a time difference of 4 minutes. So if the place is to the east, it is ahead by 4 minutes. If it is to the west, it is behind by 4 minutes in time. Let us look at a simple example about longitudes and time. If the local time at A, 40 degrees in the north and 20 degrees east, is 9 a.m., what is the local time at B, 40 degrees in the north, 40 degrees in the west? Remember, they are both at 40 degrees in the north, but they are in different longitudes. The longitude difference from A, 20 degrees in the east, all the way to B, 40 degrees in the west. These are two places on opposite sides of the prime meridian. One is to the east, 20 degrees, and the other one, 40 degrees in the west. Therefore, angle difference is 60 minutes, and we are is 60 degrees, and we have said for every 1 degree there is 4 minutes time difference. What about for the 60 degrees which we are seeing here? So it will be 4 by 60 to give us minutes, then we can divide by 60 to get hours, and this will be 4 hours exactly. So there is a time difference of 4 hours. If there is a time difference of 4 hours between these two places, then now we can say B is to the west, and it is the place where the time is not known. So we'll say that places in the west are usually behind in time. Therefore, we will take 9 a.m. and we subtract 4 hours. And this will give us 5:00 a.m. the same day. So the time at B is behind by 4 hours. That will take us back to 5 a.m. the same day. Let me describe very sensitive, something very sensitive, and that is the shortest distance, or rather the shortest route between two places which are on supplementary longitudes. Supplementary longitudes are longitudes which add up to 180 degrees. I'll give examples of such longitudes later, as we will be handling some examples. But in the meantime, let us look at this case here. There is a place, we have a latitude 50 degrees in the north, and there is the equator here, there is the prime meridian there. Then we can have two places. Let's say place A is here, 50 degrees north, and 100 in the west. That is place A. And place B is 80 degrees to the east. This is B. 80 degrees in the east on the same latitude. I want us to consider two distances here. If we move along the parallel latitude 50 degrees, what will be the distance between A and B? The distance between A and B in kilometers along the latitude of 50 will be given by the longitude difference divided by 360 multiplied by 2 multiplied by 22. Okay, I don't know why I'm substituting directly. I should have written the formula first. So we can talk about alpha over 360 2 pi r cosine of the latitude, because we are on a small circle, and therefore we'll be talking about a longitude difference from 100 degrees to the west all the way to 80 degrees in the east. We will have an angle difference of 180, because they are places on the opposite sides of the prime meridian. They are on opposite sides of the prime meridian. So we'll be talking of 180 divided by 360 multiplied by 2 multiplied by 22 out of 7 multiplied by 6370 cosine of 50, right? Cos 50. Then you carry out the multiplication. Let us look at the distance. When we take 180, we multiply by 2 by 22 by 6370 cosine of 50. Then we divide by, then you open brackets, 360 multiplied by 7. This is going to give us 12. This is going to give us a 12,868.61 kilometers. So that is the distance from A to B along the parallel of latitude. What if we calculate again the distance between A and B, but instead of moving along the parallel latitude, now we move along the north pole. We go to the north, we follow the route from A to the North Pole and down to C. Let me now show you how to go about that one. We'll be having from A to the North Pole. And first of all, we can get these angles at this point. It will now be along a great circle. Sorry for some interference here. Sorry for some interference. Sorry. Okay. Remember to continue subscribing, continue inviting friends. We should learn together. We should learn together. We should learn together. Yes. Now we are talking about from A to the north, and again from the north down to B. From the north down to B. Therefore, we are talking of, because the latitude is 50, it means from the equator to where A is, there is an angle of 50. Again, we are talking of an angle of 50 at this end. Therefore, we have said that these are supplementary longitudes. It means if we are moving from 100 degrees or through 100 degrees in the west, and we climb up to the North Pole, if we don't change the route, as we continue moving, we will find ourselves automatically along 80 degrees in the east. You are moving through 100 or along 100 in the west, but you will find yourself automatically flowing down through 80 degrees in the west. That is how supplementary longitudes behave. Therefore, you find that the path that we will be tracing in such a case is a great circle. The great circle will be having an angle at the center, which will be equivalent to, we have 50 and 50, and the total angle there should be 180. Therefore, it will be 180 minus 100, giving us 80 degrees at the center. Therefore, distance, again, in kilometers, along now a great circle will be given by theta. We have said that the theta is 80 divided by 360 multiplied by 2 multiplied by pi multiplied by radius of the earth, 6370. So this is how we get distances along great circles. So it will be 80 multiplied by 2 multiplied by 22 multiplied by 6370 divided by 360 multiplied by 7, and this will give us a distance of 8897. 8897.78 kilometers. Therefore, you can see when we move along the parallel latitude, we are getting a distance of 12,868.61 kilometers. But along the great circle, that is along the pole, we are getting 8897. That is only 8,878. So it means along the poles, distance is shorter. And so we can say shortest distance is usually shortest distance is the distance across the poles. If the two places were on the southern hemisphere, then the shorter distance could have been the distance across the South Pole. It could have been the distance across the South Pole. So before we look at examples, allow me emphasize on something. That in case we are talking about places on supplementary longitudes, we'll be talking about, let's say this is the globe. We have the prime meridian. We have the equator. Then we have a place here. This is a place, let's say it is on 50 degrees in the west. If we move through 50 degrees in the west, if we are moving from a place 50 in the west, then we move along that path to the North Pole and we fail to change the route, we continue flowing on the other side, then automatically we shall find ourselves flowing through 130 in the east. That is what we call supplementary longitudes. You move to the pole following 50 in the west, and automatically you will enter 130 in the east. If you use another example, let's say you are moving, this is a prime meridian, this one is equator. Let's say there is a place here, which is let's say 70 degrees in the east. And now there is the latitude there. You are moving along 70 degrees in the east. Then you move to the North Pole and you fail to change the route. You continue flowing downwards. You will find yourself automatically flowing along the longitude 110 degrees, but now in the west. That is the meaning of supplementary longitudes. The route is usually the same. Therefore, if two places are on supplementary longitudes, then we say that such places will have the shortest distance being across the pole. Thank you so much. I said you continue subscribing, continue sharing with friends, continue inviting people to this broadcast. Thank you so much. All right, let us now look at some examples here. Let us look at some examples. We're going to calculate them very fast. Remember to be having your calculators so that you may confirm some values. Sometimes we might make errors, but when you are having your calculator standby, you will not be involved in the errors. We are told now that a plane leaves an airport A 41 degrees 0.5 in the north, 36 degrees 0.4 in the west at 9 a.m. and flies due north to airport B on latitude 53.2 degrees in the north, taking pi as 22 out of 7 and the radius of the earth is 6370 kilometers. Part A calculates the distance covered by the plane in kilometers. So when you look at the movement of such a plane, we are moving, having the globe here, this being the 0 prime meridian, this being the 0 equator. Then we will be talking about now 41.5 in the north. 41.5 in the north. It's good and advisable for you to sketch the positions of the places once they have been stated. It's good to sketch the positions. Please take the advice. It's good you sketch the respective positions of places. Now, the place is also 36.4. So 36.4. The intersection here is giving us place A. This is 36.4 in the west. Therefore, that is where place A is. Now, a plane is going to move towards the north until we are at 53.2. So if we go to 53.2, this is a 53.2, still in the north. That means the plane has covered a certain distance from A to where B is. But now when you look at the nature of such a movement, you know, when you locate the places, you'll be able to analyze the nature of the movement. Nobody is telling us whether it is a great circle, whether it is a small circle, but after sketching, you can see from A upwards, you'll be moving along a longitude. That is along a great circle. Therefore, the angle difference from 41.5 to 53.2, they are on the same hemisphere. Therefore, you subtract. So the angle difference, beta, is going to be 53.2 minus 41.5, that is 11.7 degrees. And the distance in kilometers, strictly in kilometers, is usually given by beta out of 360, 2 pi capital R, radius of the Earth. Therefore, now we can substitute and say that the distance will be, when we have 11.7 out of 360 multiplied by 2 multiplied by pi multiplied by R, 6370. You compute this one and discover that the distance is 1301.3 kilometers. That will be the distance between the two places. The next question, part B, we are told that the plane stopped for 30 minutes. That is very sensitive. The plane stopped for 30 minutes to refuel at B and flew due east to C. Therefore, now from B, the plane is going to fly due east 2500 kilometers from B. Therefore, from B, we are going to move eastwards. So we are going to have a movement now from B towards the east, that is towards the right, until we find ourselves at a point C, where we don't know its position, that is C, but we know the distance. We should be able to analyze this question in a manner that we know that a distance in kilometers. Now from B towards C, we are moving along a small circle. That is a parallel latitude. Therefore, we are moving along a small circle. And the distance in such a case is usually given by the angle difference divided by 360 multiplied by 2 pi capital R multiplied by cosine of the latitude where the movement is happening. Therefore, now we'll be talking of the distance is already provided, 2500. This is equal to the angle difference is unknown, divide by 360. We multiply by 2 by 22 out of 7 multiplied by 6370. Cosine of the latitude is latitude 53.2. Latitude 53.2. And so we can now remain with the angle alpha by multiplying 2500 with the denominators on the right hand side. That is 2500 times 360 times 7. Then we divide by the numerators after opening brackets, 2 by 22 by 6370 cosine of 53.2. And the angle difference is going to be exactly 37.52 degrees. Therefore, there is an angle difference of 37.52 degrees when you move from point B, 36.4 degrees in the west. You cover an angle difference of 37.52. That is to tell you that if we are covering 0.52, that's 7.52, and we are already at 36.4, then we are going to cover the whole 36.4. We go even to the other side now. We go to the east, so that an angle difference of 37.52 is realized. To know the angle to the east, we need to take 37.52 and we subtract 36.4, and this becomes 1.12 degrees, which means we will be 1.12 degrees to the east. When you are 1.12 degrees to the east and the other place is 36.4 degrees, now that is a scenario which will give us an angle difference of 37.52. Therefore, for the angle difference to be 37.52, we need to be at 1.12 degrees in the east. And now we are told to state the position of C. Therefore, is given as a coordinate. We are already at latitude 53.2 in the north. Then now the longitude is determined as 1, 2, in the east. So that is how we get the distance. We get the distance, or the position, sorry, the position of C. And finally, we are told that to find the time the plane lands at sea. This is a very crucial question about the time. If the speed is 5,000 kilometers per hour, we should be able to know that time is given by distance out of speed. So the total distance covered is going to be, there is the initial 1301.3 kilometers. Then from B to C, we have 2500 kilometers, a total distance of 3801.3 kilometers. That is the total distance from point A up to B, then across to where C is. With the total distance, now we can get time. Time T will be given by distance out of the speed. So 3801.3 divided by a speed of 500. This is going to give us some hours, and that is 7 hours 36 minutes. 7 hours 36 minutes. That is the exact time taken during traveling. But it is good for us to note that there is a time when this plane was stopping at B to refuel. So we're going to have 60 because of 66. That means 1 hour 6 minutes. So we write the 6 minutes, we carry the hour to the other side, and that will be 8 hours 6 minutes consumed on the way. Then there is something else we are supposed to understand, that there is time difference in these places. When it was 9 a.m. exactly, at the time the plane was leaving A, remember it was 9 a.m. At 9 a.m. at A, it was also 9 a.m. at B, but for position C, time was very different. Time was totally different because it is on a different longitude. It is actually ahead in time because it is to the east. Therefore, we first of all get the time at C, which is equivalent to 9 a.m. at A. So time at C, when the plane was starting the journey, remember the longitude difference has already been obtained as 37.52. And now we have to say that 1 degree equals to 4 minutes. What about 37.52 degrees? And this will give us 4 multiplied by 37.52. Those will be minutes. We can now divide by 60 so that we get the time in hours. And this will give us 2.5 hours, which means 2 hours 30 minutes. So initially, C was or C is 2 hours 30 minutes ahead in time. 2 hours 30 minutes ahead in time. Therefore, we will start with 9 a.m. We first of all add the time difference because C is ahead in time, and this will give us 11:30. So 11:30 is the time at C when the journey was starting, but now the journey has taken 8 hours. So we add 8 hours 6 minutes, and this will give us 19:36 hours the same day. That will be the arrival time at C. Thank you so much for following. Continue subscribing, continue sharing with friends. We are learning together. Thank you so much. I can see people are joining wonderfully. People are chatting live. Yeah. Thank you so much. I can see your comments. And your questions. I'll be attending to you. Thank you so much. Thank you so much. Thank you so much. All right, let us look at another question. Number 2, we are almost winding up. Thank you for staying vigilant. An airplane leaves town A, 83 degrees north, 155 degrees in the west, to town B, 40 degrees in the north, 25 degrees in the east, using the shortest route. So the language there is shortest route at a speed of 450 knots. When the language is 450 knots, remember knots is when speed has been calculated using distance in nautical miles. That one has to be mentioned. 450 knots means nautical miles per hour. Pi is 22 out of 7. Radius of the Earth is 6370 kilometers. Part A, Roman 1, calculate the distance between A and B in nautical miles for 2 marks. It is now along the shortest route. Latitude, it is along the North Pole. Therefore, a place is at 83 and another one at 40. This means if we got the equator here, for us to know this is equator 0 degrees, equator, allow me have it as a straight line. So we have, from the axis of the Earth, we are supposed to measure an angle of 83. An angle of 83 degrees toward the north, and that will tell us where point A is. Then another angle of 40 degrees in the north will help us to know where point B is. This is an angle of 40 degrees to the north again. Therefore, because we are moving along 155 to the pole, we will find ourselves flowing along 25 degrees in the east automatically. That is something which I've already explained about supplementary longitudes. Therefore, now, if we move to the North Pole, from this place now, this is A, we move to the North Pole, we will go down. If this is 25 degrees in the east, this is automatically 155 degrees in the west. Therefore, we move to the North Pole, following 155 to the west, and we will find ourselves flowing downwards now, after the North Pole, downwards, following 25 degrees in the east. Those are supplementary longitudes. Now we are having an angle at this point now. That is a great circle. That is movement along a great circle. And the angle at that point is going to be exactly the angle difference there. When you subtract 180 and 83 plus 40, you are going to get exactly an angle of, let me use my calculator, 180 minus, there is 40 and 83. This is going to give us exactly 57. Therefore, the angle is going to be 57 degrees. So an angle of 57 degrees. Now with an angle of 57, we are able now to talk about distance, but now in nautical miles. So it will be 60 multiplied by beta, because it is along a great circle. 60 by 57 is going to be 3420. Yeah, 3420. So that is going to be 3420. 3420 nautical miles. 3420 nautical miles. That will be the shortest distance. The shortest distance. Calculate also the time taken to travel from A to B. Time taken is usually given by distance out of speed. So a distance of 3420 and a speed of 440. Yeah, these are nautical miles. So we divide by 450, the speed. So when we divide by 450, we're going to get 7 hours then a 0.6, which means we can subtract 7, we multiply by 6, and that will be 36 minutes. That will be the time taken, 7 hours, 36 minutes. Again, we are told that from B, the plane flies westwards along the latitude to town C, 40 degrees in the north, 13 degrees in the west. Therefore, now we are moving. Remember, we have already landed at 40 degrees north. And the place here, place B, has been given to be, place B is 25 in the east. So place B is 25 in the east. Now we are moving along the parallel to the west up to 13 degrees in the west. That means there is an angle difference covered here from B to C. B is 25 in the east, C is 13 in the west. Therefore, the angle difference there is going to be 13 plus 25, giving us 38. Therefore, we'll be talking about distance. Distance in kilometers along a small circle, which will be given by angle difference divided by 360 times 2 times pi times capital R cosine of the latitude where the two places are. And this is going to be an angle difference of 13 to 25 will be 38. 360 multiplied by 2 multiplied by 22 out of 7 multiplied by 6370 cosine of latitude 40. The two places are at latitude 40. That is going to be 3237.64 kilometers. So that will be the distance between the two places. Part C is talking about from town C, the plane took off at 3:10 p.m. towards D, which is 10 degrees north, 13 degrees in the west. Therefore, we are still at 13 degrees in the west, and now we are moving again downwards now. We are moving downwards from 40 north until D, which is 10 in the north. Therefore, we are going to move down the way to 10. If we sketch again, now we will find ourselves at 10 in the north, which means we are moving from 40 degrees to 10 in the north, and that means it's along a great circle, Therefore, first of all, let us get the time. Let us get the distance covered, Distance in kilometers along a great circle will be the latitude difference. From 40 down to 10 will be an angle difference of 30 over 360 times 2 times radius of the earth, 6370. That is how we get distance along a great circle. And now with that, we are getting a distance of the distance is going to be, let me work it out, 30 multiplied by 2 by 22 multiplied by 6370, then we divide by 360 by 7. This gives us 36.67 kilometers. But again, there is something we are supposed to discover, that such a distance, because the speed which was provided was here, the speed is nautical miles per hour, rather in knots, then we are required to calculate the distance along the great circle in nautical miles. So the same distance in nautical miles will be 60 times beta, the angle difference of 30. This gives us 1800. Therefore, we can now get the time taken, which will be 1800 nautical miles out of 450 the speed, and this will give us exactly 4 hours. So with time taken as 4 hours, and we are moving along the same longitude, which means moving along the same longitude, there is no time difference. So we are simply going to add to 310. We are adding 4 hours. And this will be exactly 7:10 p.m. the same day. That is the time of arrival. We are finishing up. I want to handle questions which are testing almost all the concepts in this topic. Consider points A, 50 in the north, 30 in the east. And again, there is B, 50 in the north, 150 in the west. Pi 22 out of 7, radius of the earth 6370. Find part A, the distance between A and B along a parallel of latitude in kilometers. So from A to B, the distance in kilometers, from A to B, the distance in kilometers along the parallel of latitude. Remember, we are moving from 30 in the east all the way to 150 in the west, which means there is an angle difference of 180. Divide by 360, multiplied by 2, multiplied by 22 out of 7, multiplied by 6370, cosine of the latitude where we are moving across, that is latitude 50, is going to be exactly, you will get exactly 12,868.61 kilometers. That is the distance in kilometers. There's also the distance in nautical miles. Distance in nautical miles along a small circle will be given by 60 times alpha cosine of the latitude. Therefore, we'll be talking about 60 times angle difference of 180 cosine of latitude 50. And this is going to be computed using a calculator, and it will give you 6942.11. These are nautical miles. There are more questions like part B, which is telling us to find the shortest distance from A to B in nautical miles. So from A to B, for us to get the shortest distance, we shall move along the great circle, such that if this is the equator, the two places are at 50 degrees in the north. The other one is also 50 degrees in the north. Therefore, when we move along 30 in the east, we are going to find ourselves along 150. So if we go to the North Pole, following this longitude 30 in the east, where point A is, that is where A is, and we move to the North Pole, we will flow downwards following longitude 150 in the west. Therefore, now that is a great circle, and that is the shortest route. And the angle at this point, because 50 and 50 gives 100, it will be 80. Therefore, we will be talking about the shortest distance in nautical miles. Because it is along a great circle, it will be theta times 60 times theta. The theta is 80. So 4800 nautical miles will be the distance. And furthermore, we are told that an aircraft takes 54 hours to fly between towns A and B along the Great Circle. Calculate its speed in knots. Calculate its speed in knots to two significant figures. Very special instructions. We are supposed to know that the distance already, for us to get speed, we need distance out of time. And the distance between A and B along the Great Circle has been obtained up there as 4800. Therefore, when we divide by speed, because the distance is already in nautical miles and there is time taken as 54 hours, we will directly get knots, and we are going to get 88.89. 8.89 nautical knots. But now this speed has to be written to two significant figures. The first significant figure is 8. The second significant figure is also 8, but 8 can be increased by the third significant figure. So it will be 89 knots. That will be the answer expressed in two significant figures. So that is how we get the speed. Thank you so much. Continue inviting friends. We are winding up. The last question now, number 4. An aircraft leaves airport P, 50 in the north, 5 in the west, and flies due west for 2400 kilometers to point Q. Then 1500 kilometers due south to point R. Given that the radius of the Earth is 6370, find the position of Q. We are moving from P all the way to Q, and it is due west. When you are moving either due west or due east, you are moving along a small circle. When you are moving either northwards or southwards, you are moving along a latitude, and that is a great circle. Therefore, in this case, we are moving to the west, and that means along a small circle. The distance is already known. Distance is 2400. This distance is supposed to be given by change in longitude, divide by 362 times pi times 6370, that is the radius of the Earth, cosine of the latitude where we are moving along, that is latitude 50, because the P is at 50 and we are moving westwards. That means we will still move along that latitude of 50. Therefore, we can remain with the angle difference. For us to get theta, we need to multiply with the denominators here. So 2400 times 360 times 7. Then again, we divide by the numerators. So open brackets and you multiply 2. You divide by 2 times 22 times 6370 cosine of 50. And that will give us an angle difference. This is the last question. An angle difference of 33.57 degrees. 33.57 degrees. So with an angle difference of 33.57 degrees, 33.57 degrees, now we can say that we were at 5 degrees in the west, and we are moving further to the west. We are moving further to the west. That means we should add, for us to know the longitude of Q. We are supposed to add 5 to give us 38.57. Therefore, the position of Q will be 50 degrees in the north, 38.57 in the west. Yeah, for us to get 33.57 as the angle difference, we need to be at 38.57. Then we move to 5. The angle difference there will be just as it has been obtained here. Therefore, we add 5, and that is how we get the longitude of point Q. As we wind up, we are also finding the position of R. Position of R, we are told the plane is moving again due south, which means to move due south, we are moving along a great circle. Along a great circle. Remember, we are at 50 degrees in the north, and now we want to move downwards. We want to move downwards to 1500. So 1500 is a distance along a great circle, and it's given by change in longitude, which we don't know. So theta out of 360 multiplied by 2 multiplied by 22 out of 7 multiplied by 6370. That is how we get the distance along a small circle. Therefore, now theta can be obtained. When we take 1500, we multiply by 360 by 7. Then we divide by, you open brackets for 2, 22 times 6350. Then we are going to get an angle difference of 13.49. 13.49. Which means if the angle difference covered now from 50 north going downwards is 13.49, we are still in the northern hemisphere. We have not crossed the equator. to the southern hemisphere. Therefore, we are going downwards to the south, but we are still at the north, because 50 minus 13.49, we will find ourselves still at 36.51 degrees in the north. This is the longitude of R. When you move from 50 downwards through an angle difference of 13.49, you will find yourself at 36.51, still in the north hemisphere. Therefore, the position of R now will be given by 36.51 degrees in the north. Then we are flowing downwards through 38.57 degrees in the west. So that is the position of R. To finish up, we have a part C here. C says that a ship leaves Mombasa 4 degrees south, 40 degrees in the east, and sails due east 4 hours to point Q, which is also 40 or 4 degrees in the south, 52 in the east. Therefore, moving from 40 to the east and finding ourselves at 52, still in the east. This is to mean that we have moved to the east, and the angle difference between the two places we will subtract. Find the average speed of the ship in knots. When we are talking about speed in knots, that is to advise us that the distance is supposed to be in nautical miles. So the units of speed are directing us on the units of distance to have, and that is going to be distance in nautical miles along a small circle, because we are moving eastwards. That will be along a circle of latitude. This is going to be we are moving from 40 in the east all the way to 52 in the east, which means 52 minus 40 is just 12 degrees. So the angle difference is 12. So 60 times theta, 12, cosine of the latitude along which the movement is happening. And this is latitude 4 degrees, so cosine of 4. And when we compute this distance, it's going to be 718.25 nautical miles. That is the distance, which means for us to get now the speed, because the distance is already in nautical miles, then speed will automatically be distance in nautical miles out of time in hours. 718.25 divided by the time which the plane took, or the ship took, sorry, was 30 hours. So we divide this by 30. And when you divide by 30, you are going to get a speed of 23.94 knots. This is the speed in knots. Thank you so much for following. This is my number. I've seen some people requesting for revision papers, others appreciating me through the same number. Some parents are sharing their airtime and some bundles through that number. May God continue blessing you. Remember to share this broadcast and to subscribe more. Thank you so much.